I am taking lecture on solid waste management. Solid waste management include the activities and action required to manage solid waste from its inception to its final disposal. Solid waste management is intended to reduce adverse effects of waste on human health, environment, or aesthetics. Waste management practices are not uniform among countries, like the developed countries and the developing countries. They may have the different approaches regarding the solid waste management. Regions, urban regions or rural areas, residential or industrial areas, all can take different approaches to manage the solid waste. Here are the elements of solid waste: generation, on-site handling or storage, collection, and disposal. In between there are two steps. Either we can go disposal by the processing unit, or we can directly transport the waste up to the disposal point. Generation of solid waste is a result of natural, human, and animal activities. Knowledge of generation of solid waste is important in the planning, designing, and operation of solid waste management system. Generation has two aspects. One is the quality of the solid waste, and the other is the quantity of solid waste. Quality include the sources, types, and typical composition of solid waste along with its properties, whereas the quantity represents the generation rates, total quantities, and volume of waste generated. Waste storage. The first phase to manage solid waste is at home level. It requires temporary storage of refuse on the premises. For individual homes, industries, and other commercial centers, proper on-site storage of solid waste is the beginning of proper disposal, because attended solid waste or improper dumps are sources of nuisance, flies, smells, and other hazards. On-site waste handling. Handling refers to activities associated with managing solid waste until they are placed in the containers used for their storage before collection and recycling centers. The specific activities associated with handling waste materials at the source of generation will vary depending on the types of waste materials that are separated from the waste stream. Depending on the type of collection service, handling may also be required to move the loaded containers to the collection point and to return the empty container to the point where they are stored between collection. Collection includes not only the gathering or picking up of solid waste from the various sources, but also hauling of these waste to the disposal site or transfer station and unloading there. While hauling and unloading are similar for most collection systems, the collection or pickup of waste varies with facilities and location. Based on mode of operation, there are two types of collection methods: hauling container system, stationary container system. Hauled container system. An empty storage container is hauled to the storage site to replace the container that is full of waste, which is then hauled to the processing point, transfer station, or disposal site. Here we are seeing the picture. This is the hauled container system. Here the vehicle stand alongside this container location, and here he put the one empty container here and loaded the full container of the waste. and then move to the location 2 and as well as location 3, and finally all empty container put and at the place, and the loaded container put on the vehicle and move to the processing unit, transfer station or disposal site. Stationary container system. Containers used for the storage of waste remain at the point of collection. The collection vehicles stop alongside the storage container and waste load from storage container to the collection vehicles for transporting the waste to the processing, transfer or disposal site. Here the vehicle stands alongside the container or collection container, and empty this container into the vehicle and put the container at that place, and vehicle moves in another point, and finally the loaded vehicles move to the processing, transfer or disposal site, and the container remain at that place. Transport. Transfer and transport refers to the means, facilities and appurtenances used to transfer of waste from one location to another, usually more distant location. Typically, the waste from relatively small collection vehicles are transferred to larger vehicles and then transported to distant location. Here the some vehicle used for the collection from the generation point and the transportation of the waste up to the disposal site or processing units. Hand carts, tricycle, tri-rickshaw, auto rickshaw, tractors, standard trucks, fore and aft tipper. This in this vehicles, these boxes can move in an angle so as the loading and unloading as well as the complexion has been done. And here is the compactor truck with where a compactor also included in this truck, so as more waste can be adjusted in this truck. Processing. Resource recovery is the process of collecting discarded items for another useful purpose. Recycling is the process of converting waste product into new product to prevent energy uses and consumption of fresh raw materials. Discarded items are processed to extract or recover materials and resources or convert them to energy in the form of usable heat, electricity or fuel. Waste to energy help to reduce carbon emission by offsetting the need for energy from fossil sources. Over time, this reduces global warming and makes our environment better. Composting. Composting is an easy and natural biodegradation process that takes organic waste, remains of plants, garden and kitchen waste. It occurs by allowing organic materials to keep in one place for months until microbes decompose it. Composting can turn unsafe organic product into the safe compost. The process, however, has its downside. It is slow process and takes a lot of space, and here oxygen is required for the process. On-site composting. Organizations that are going to compose a small amount of wasted food can compose on-site. Composting can significantly reduce the amount of wasted food that is thrown away. Yard trimmings and small quantities of food scraps can be composted on-site. Animals products and large quantities of food scraps are not appropriate for on-site composting because it is for the small purpose. So here the one container, plastic container is available for that purpose, or here some small cemented covered cemented area is available for the on-site composting. Vermicomposting. Red worms in bins feed on food scraps, yard trimmings, and other organic matter to create compost. The worms break down this material into high quality compost called castings. Worms bins are easy to construct and are also available for purchase. 1 pound of manure worms, approximately 800 to 1000 worms, can eat up to half a pound of organic materials per day. The bins can be sized to match the volume of food scraps that will be turned into casting. The casting can be used as potting soil. The other byproduct of vermicomposting, known as worm tea, is used as a high quality liquid fertilizer for household, house plants or gardens. Here worm tea, we can say the byproduct which remain as a liquid in the process of this composting, which is here known as the worm tea and used for the as a liquid fertilizer. Here this is the earthworm used for that vermicomposting. Aerated windrow composting. Aerated windrow composting is suitable for large volumes such as that generated by entire communities and food processing businesses. Example: restaurants, cafeterias, packing plants. It will yield significant amounts of compost. Local government may want to make the compost available to residents for a low or no cost. This type of composting involves forming organic waste into rows of long piles called windrows and aerating them periodically by either through pipes, manually or mechanically turning the piles. The ideal pile height is between 4 and 8 feet with a width of 14 to 16 feet. Large volumes of diverse waste such as yard trimmings, grease, liquids, and animals byproducts such as fish and pottery waste can be composted through this method. Here either we are making the small rows of this waste material for the composting so as the microorganisms get easily the oxygen. Otherwise we can use the this pipe where holes are available in that in whole length of this pipe, so as and they kept between the piles, large piles, so as the oxygen easily enter in that area and microorganisms can work to make the compost. In vessel composting process large amount of waste without taking up as much space, and it can accommodate virtually any type of organic waste. Example: meat, animal manure, food scrap. This method involves feeding organic materials into a drum, silo, concrete lined trench or similar equipment. This allows good control of the environmental conditions such as temperature, moisture and airflow. The material is mechanically turned or mixed to make sure the material is aerated. The size of the vessel can vary in capacity or size. This method produces compost in just in a few weeks. It takes a few more weeks or months until it is ready to use because the microbial activity needs to balance and the pile needs to cool. Because in this method initially we can convert the food waste, scrap waste food or other organic waste into less harmful byproduct, and then finally we can compose after keeping few more weeks to in this type of waste in open area, so as useful compost we can get. So here we are seeing the machine. This is maybe the manually or the electrically operated for the purpose. Incineration or combustion. In incineration or combustion, solid waste are burned at high temperatures. The process eventually converts them into residues and gaseous product. The biggest advantage of this type of method is that it can reduce the volume of solid waste to 20 to 30% of the original volume. Additionally, it also decreases the space they take up while also reducing the stress on landfills. Incinerators are primarily used in thermal treatment where solid waste materials are converted into heat, gas, steam and ash. Here we can see a simple line diagram of the incineration plant. A truck came for unloading the organic waste, and it is collected in that place in that place we are seeing, and the crane lift this waste and charge the hooper where it is goes into the furnace and at a temperature, and after coming from here the ash or the flue gases are remain, and flue gases can be go out to the stack after some using the cleaning equipment. Landfill or sanitary landfill. Throwing daily waste garbage in the landfill is the most popular used method of waste disposal, but this method requires lot of space. There is presence of methane and other landfill gases in this method, which can cause numerous pollution problems. Landfills give rise to air and water pollution, which severely affects the environment and can prove fatal to the lives of humans and animals. Here we are seeing the landfill site. So criteria to unload the waste here like this. Firstly, we make the plan lift 1, lift 2, lift 3, lift 4 like the plan, and the waste is decomposed. Waste is disposed in figure like in last point. Then this area is covered. Then we again fill the waste here and then cover by the soil, and this processing going on, and finally we cover the complete area, and we can use for the other purpose when once this landfill site completed is life tenure. Here we are seeing the problem of the methane gas formation, because methane gas is very harmful and can make the fire at that place. So there is a passage is given by using the gravel or the perforated pipes to let off the methane gas in the atmosphere. Here we are seeing one more problem in the landfill. This is the problem of the leachate. This is the liquid comes after the anaerobic decomposition of the organic waste, which is landfill in the landfill site. So there is some impervious bottom liner is done to trap the leachate so as this leachate cannot go under the underground area or pollute the underground water. And in same pattern, there is a impervious cap is maintained at the top position, so as this leachate cannot flow from here, and after flowing could not merge in the surface runoff, so as there may not be the chances of the water pollution. So one important term comes in that category: integrated solid waste management. We are doing the solid waste management, but in that case we consider all the stakeholders and the factor which may include this in management of this solid waste. So stakeholders may be the local authorities, NGOs, communities based organizations, service users, private informal sector, private formal sectors, donor agencies, or factors may be the technical, environmental, finance, economic, social, culture, policy, legal, political, all factors will be considered, and considering all these factors, a process time takes place, and finally we do the integrated solid waste management for the sustainability. This is the in short of the integrated solid waste management. We can do a lot of in that area. New technologies for solid waste management. Underground collection system. In this method, waste bins or containers are being replaced by underground collection points. This includes the placement of plastic container in excavation of 2 to 3 meter, and only inlet point is in environment. So only inlet point means where we dump the our waste. Only that portion is open, and all other portion is underground. The technology is beneficial for the regions with extremely hot climatic condition, as the waste would be stored underground in relatively low temperature. Technology requires less maintenance and is more aesthetically acceptable. Wave-based GIS technology. The coupling of waste collection and wave geographic information system oriented GIS oriented system, or we can say the geographic information system, has become increasingly used. It is a structured and integrated application for managing the entire cycle of waste from the point of production to the landfill or to the recycling or treatment plants by automating and optimizing each step of the chain. The implementation of wave-based GIS technology optimized the waste collection. Source separation for recycling had become efficient up to 80%. As GIS can model the world landmark and streets, it can play an important role in waste collection sector. GIS in combination of other software can give information regarding the most reliable routes, numbers of residents, number of contracts, their validation, and potential frauds. Waste bin monitoring technology using Global System of Mobile GSM. In this technology, sensors are placed in public garbage bins to detect a certain optimum level of waste. As the garbage reaches the threshold level, indication will be transferred to the controller, which will further give indication to driver of collection truck for emptying the bin urgently. The indication will be sent to the driver through SMS using GSM. Multi-compartment bins. Recently, developed countries including Sweden are using multi-compartment bins for source segregation of waste. These type of waste bins have separate compartments for different types of waste. Through this, organic, paper waste and recyclable can be segregated on the spot of generation, while recyclable can be recycled or reused, as through this method contamination can be avoided. Optical sorting. Different types of plastics, composites and other waste are being sorted with the help of color sensitive cameras, UV sensor and infrared spectroscopy. With the help of sensor, the position of different waste components are identified. This type of sorting is most commonly used for glass waste. Latest technology included optical sorting with laser, which is relatively expensive. According to the studies, this technology can reach a purity of 99.7% for flint glass. Automatic bottle sorting system. This technology is widely used in Japan in recent years. It is comprised on sizing, aligning and clearing machine along with color identification sensor. The role of sizing machine is to divide the bottles according to the size, after which bottles will send to color sensing machine and then conveyor belt. The bottles of each color are threaded and cullet is prepared. Through this volume of waste is reduced and cullet can be further used in different fields. De-inking technology for paper recycling. In developed countries, de-inking technology was introduced few years ago. It is still latest in some developing countries. Through in this process, paper ink is removed from recycled paper slurry. In Europe, the annual production of de-inked pulp has to be increased up to 15%. Frequent recycling of newspaper and printed white paper can challenge the quality of paper. According to studies, newspaper can be recycled up to 5 times. Cullet remanufacturing. Mostly glass bottles are used for refilling after returning to the shops and companies. Latest technology have been introduced for the remanufacturing of broken glass pieces called cullet. The cullet undergoes melting and remanufacturing of glass bottles or containers. Cullet is also used as substitute in building materials and as raw materials in insulation. Autoclaving. The technology involves treating the waste with steam at 140 to 160 degrees centigrade for 30 to 40 minutes. This sterilizes the waste and the residue is subjected to screening. This is mostly can be used in the case of the biomedical waste. Where waste is separated on the basis of weight, organic fiber is segregated from glass and dirt, metals and plastic will send for recycling. The organic fiber has many uses including land application and as fiber in construction industry or in the making of refuse drive fuel. The residue of the process is then sent for disposal to the landfill site. Plasma gasification. Plasma gasification is another form of solid waste management. Plasma is primarily an electrically charged or highly ionized gas. Lightning is one type of plasma that produces very high temperatures. With this method of solid waste disposal, a vessel uses characteristic plasma torches operating at 10,000 degree Fahrenheit, which is creating a gasification zone till 3000 degree Fahrenheit for the conversion of the solid waste into a syngas. In plasma gasification, molecular bonds of solid waste are broken down as a result of the intense heat in the vessels and the elemental component. Fluffing. Recently, a processing method has been evolved in which the solid waste is separated, sterilized, and the organic portion is processed to form pulp-like material known as fluff. Many processing facilities have shredders which reduce the size of waste up to 2 to 5 cm. Batteries, carpet and other type waste is separated manually. The reduced size product is then transferred to conveyor stream where metallic portion separated out. High temperature steam is then introduced for further breaking of molecular bond which destroy pathogens. The product is further grind, dewatered and separated from other type of waste. The remaining is a fine cellulosic material emerges as sanitized sand-like granule fluff. The fluff byproduct can be used as soil amendment because of its organic base and high nitrogen content. If not utilized so, the fluff can enter the landfill with 30 to 75% reduced volume as compared to original content. So here we are seeing the picking up of the iron ferrous materials by using the magnet which is available here, and in a conveyor shredded solid waste comes and the ferrous materials is attached with that magnet, and when moving further they separated as a ferrous or non-ferrous materials. The benefits of solid waste management. There are multiple benefits to treating and managing solid waste. Better environment. Probably the biggest advantage of managing solid waste is that it eventually leads to a better and fresher environment. Waste disposal units contribute to the well being of the people by helping them to become disease free. All of this happens when solid waste is duly disposed of in a proper and sanitary manner. Create employment. The recycling industry alone creates hundreds of jobs. Reduce pollution. When waste is managed the right way, it does not merely eliminate the subsequent waste but also reduces the impact and the intensity of harmful greenhouse gases like carbon dioxide, carbon monoxide, and methane that are often emitted from accumulated waste in landfill. Conserves energy. Recycling is one of the biggest aspects of waste management, and over time it helps conserve energy. One of the biggest instances of this advantage can be traced to the practice of recycling paper. When a used paper is recycled to create new paper, the need of cutting trees is significantly minimized. This helps conserve energy while also reducing your carbon footprint. Means when we are using the already when we use the already available used paper for making the paper new paper, so there is a we are not less dependent on the trees, so we are less dependent on the conservation on in the process of making this paper, so we can save the energy, water, and trees, so we can reduce the carbon in this way carbon footprints. And all this is about the solid waste management. Thank you.